In this video, we'll talk about the reference architecture. So it is a starting point for generating concrete architectures and actual systems. So we have seen this figure before. From the reference architecture, we generate the concrete architecture, and then we move on to actual systems. Concrete architecture addresses the concerns of multiple stakeholders of the actual system, and it is typically presented in a series of views. So basically, for the discussion in this video, we'll talk about different views. And reference architecture, on the other hand, serves as a guide for one or more concrete system architects. So that's the relationship between concrete architecture and reference architecture. For the concept of views for representation of architecture is also useful for IoT reference architecture. So for views in the architecture, so it is in the construction. So we see that we can look at the front of a building, look at the side of a building. So basically we look at the same thing from different aspects. So the same idea is also used in the reference architecture in IoT. They are useful for reducing the complexity of reference architecture benefits by addressing groups of concerns one group at a time. Basically, the reference architecture is to be used by different stakeholders. So for different stakeholders, basically you need to talk the things they are interested in and they can understand, right? So basically for example, you don't want to talk about the material mechanics to a student in the art school, just for example, because that's not his or her language. So for the views in the reference architecture, basically it describes the corresponding aspects for the corresponding stakeholders. When we talk about stakeholders, so for a concrete IoT system, we have the following stakeholders. Of course, we have the people who use the system, we have people who design, build the resources, we have people who deploy, we have people who integrate capabilities, we have people who operate, maintain, and troubleshoot the infrastructure. We also have people who buy and own a IoT system themselves. So those are different stakeholders. So in order to address the concerns of mainly the concrete IoT architect, and secondly the concerns of most of the above stakeholders, so we have chosen to represent reference architecture as a set of architectural views. So by saying this, we indicate that these views are just a few examples of the reference architecture, but the most popular and most of the time, especially under the context of IoT, they are required. So for these views, they include functional views, describe how the system works, right? Information views, describe how the information created, collected, and handled in the system. And also the deployment and operation view, it describes the main real-world components of systems such as devices, network routers, servers. Basically, how to put this design into reality. So with that being said, let's begin with the functional view. So the functional view of the IoT reference architecture is represented in the next figure. So it consists of the functional groups presented earlier in the functional model, and each of which includes a set of functional components. Okay, FC stands for components. So actually it looks like this way. So if you remember the functional model, you will remember that we have the functional groups here already, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 functional groups. But for the functional view, because we are looking into how these groups actually work, so for each functional group, we have the functional components like this. Basically, we elaborate the functional groups. For example, for the management, we have the configuration function component, Fault FC, reporting FC, member FC, and state FC, something like that. So basically, it is a detailed version of the functional model. Okay, now let's look at these functional groups into a little more detail. Basically, we describe their main functional components. So for the device and application functional groups, they're already in the IoT functional model. So the device function group includes the sensing actuation tag, that's what I described before, and also processing and storage functional components. For the application functional group, you have the standalone applications and business applications. So straightforward. For the communication functional groups, you have three types of functions. You say the hop and hop, and network and communication, and end-to-end communication. So hop to hop means that, do you remember the capillary network? So we have the nodes and the links, right? So hop to hop indicates, for example, the Wi-Fi network in your house. Actually, it is a network. In that case, the hop to hop communication cares about how the devices in your house can interact with each other, can communicate with each other. For the network communication, the network functional component is responsible for message routing and forwarding the necessary translation of various identifiers and addresses. Basically, it deals with the communication from inside the capillary network to the outside. And for the end-to-end communication, basically it deals with how different networks can communicate, how components in different networks can communicate with each other. For example, how the laptop in your house can communicate with the laptop in my house. For example, basically the data or the information from your laptop need to go to your Wi-Fi router first, and then go to the access point, and then you go to the internet, and then from the internet you need to go to my gateway, and then from my gateway go to my router, and from my router go to my laptop. Basically, that's end-to-end communication from your laptop to my laptop. So that's how it works. So in that case, you just need to for this unit, what you need to do is by describing the functions here, you will be able to tell what kind of functional component it is. So that's already more than enough. So once again, the italic fonts here are just helping you to get an idea, but the description here is quite general and straightforward. And then we have the IoT service functional group. It has two functional components. So once again, we are moving for each functional group. We have several components, and they try to achieve different functions, of course. For example, the IoT service FC is a collection of service implementers which interface the related and associated resources. And we will have a figure later using the parking lot example to help you better understanding this. So the IoT service resolution FC, so there are two different FCs, okay? Contain necessary functions to realize a directory of IoT services, something like that. And for the virtual entity functional groups, it contains functions that support the interaction between user and the physical things through virtual entity services. So it has the virtual entity service FC, virtual entity registry FC, the virtual entity resolution FC, virtual entity and IoT service monitoring FC. These are the brief description of them. So once again, you just need to be able to tell the name of the FC based on the description of their function. That's good enough. So you can expect some multiple choice questions in your final exam. Basically, I describe some functions here. You should be able to got the corresponding FC. And then for the IoT process management functional groups, we have the process modeling FC and process execution FC. So you can read it yourself. And for the service organization functional group, it has the service composition FC, service orchestration FC, service choreography FC, something like that. And for the security function groups, we have the identity management FC, authentication FC, authorization FC, key exchange and management FC. So the key here is the keys for encryption and decryption. For example, the public key and the private key, and also the trust and reputation FC. Okay, don't forget the management functional groups. It is the management of the system as a whole. It has the configuration FC, fault FC, it's straightforward, member FC, state FC, and reporting FC. So that's for the functional view. Basically, it just elaborates functional groups in the functional model, in the reference model with the functional components in each functional groups. Yeah, so if you can figure out this relationship, then it's easy for you to organize the information. And for the examination, it's open notes, so you can always come back to find this information. But it will just be beneficial that if you can figure out the structure of what we discussed here, so that you know the relationship. It's easy for you to organize the information. Okay, just now we finished talking about the functional view, which talks about the functions of different components. Now let's look at the information. So the information view consists of the description of information handled by the IoT system, and also the way this information is handled in the system. Basically, it describes what is handled and how it's handled, right? In other words, the information lifecycle and flow, and the information handling components. Basically, what's there and how it's handled. For the information in the IoT system, as you can imagine, it involves a lot of information. So for example, virtual entity context information, IoT output, virtual entity description, something that basically, we need 2 slides to show some of them. Okay, but most of them are easy to understand because there are so many entities, there are so many interactions. Of course, we have many many information. Okay, now let's see how this information is handled. An IoT system is typically deployed to monitor and control physical entities. So monitor, we use sensors. Control, we use actuators. And the tags can help us with this purpose, right? And monitoring and controlling physical entities is typically performed by many devices, communication, IoT services, virtual functional groups in the functional view. That's what we showed before. And also it involves some of the functional components in other functional groups. Okay. Information handling of an system depends largely on specific at hand. Basically, there are just four typical patterns for information exchange. So the exchange of information between functional components follows the interaction pattern below. First is push. So it's illustrated in the figure, so easy to understand. So basically, as the time goes, object A or functional component A just push the information to functional component B. Basically, just like you and me. So every week, I shout out that homework is due by the weekend. So that's kind of a push, right? And another typical way is the request and response. So easy to understand. Actually, it's also used a lot in the internet. So FCA, functional component A, just send a request to functional B saying that, okay, I need to have this information, this data, and functional component B receive this request and then just send back the response to FCA. For example, the data FCA is requesting or just send an error message to functional component A. Another way for exchange of information is subscribe notify. So multiple subscriber components can subscribe for information of component C, and C will notify the relevant subscriber when the request information is ready. So that's really easy to understand if you use YouTube, right? So I'm not sure whether you subscribe to some YouTubers. So basically, after you subscribe, whenever he or she has a new video or a new post, then it will come up from the main page of your YouTube website, right? So that's how it works. So it is illustrated using this figure. So SA and SB subscribe C, telling that, okay, I'm interested in your data, in your information. So whenever B and whenever C has updates, so it will notify A and notify B. So a similar method is the publish and subscribe method. So in this pattern, there's a component called the broker B, which mediates subscription and propagation between subscribers and publishers. So what it does is just like this figure. So SA and SCC subscribe to B, telling that, for example, I'm interested in news related to who? Let me find it. To Apple, for example, of Elon Musk. Yeah, let's use him as well. So SA and SB, SA and SC subscribe to B, telling B that they are interested in information from Elon Musk. And then later, Elon Musk publish an information. And then B will send the information to SA and SC. Basically, we have a broker there. So the benefit of, basically you may notice C and D are quite similar here. The benefit of introducing a broker is that the management will be easier. So that for the P, he just need to focus on the publishing the data. He didn't need to deal with the subscription notification mechanism, right? Because for broker B, it will deal with this, and also that can hide the identity or hide P in the network, because sometimes this data are from some some sensors or some devices that should not be interacted with ordinary people. In that case, it will not be a good idea for SA and SB to interact with the P directly. But with the introduction of broker B, basically we have a kind of a defense, or we can call it a barrier to protect the publisher. Okay, basically these are few examples of information handling by FC, and it is not complete. Just to let you know. So with that in mind, so I have some more complicated examples in the next few slides showing the communication. So for example, in this scenario, so you see the first step, the sensor push the data to the components here, right? To the functional components here. Why do we use push? Because the sensor may be just programmed to update the temperature every hour, right? And then after the information goes through these functional components in the communication functional groups, and then it push to the IoT service. And then for a user, he may want to check the temperature, right? So he uses maybe a browser to send a request. That's that. And then IoT service will give a response to the user telling about the temperature. Okay, and also the IoT service may use the subscribe and notify mechanism with the virtual entity service. Basically, for the user, he may subscribe the service of temperature update. So in that case, when the temperature is updated, so the user will will notify about the sensor update. So in that case, he may receive a push an update email, warning email, something like that. In this case, the user number 2 does not initiate the request of temperature. So it is not like user one. User one, he uses a web browser, typing information and then enter and then ask for the information. But for user two, he or she is under the subscription. So whenever there's a temperature update, he or she will get a notification. So So for the slides here, it is basically describe what I mentioned. So you are more than welcome to have a reading on them. And also there are other scenarios. So this one is a little bit different. So I will leave this for you to read. Basically with the description in these slides, as well as the figure, it's easy to follow. Basically they just they're just communicating based on the 4 patterns we described before. You see, so for this scenario, so the service choreography. So the CEP here, complex event processing here, they subscribe to IoT service A and B here, right? So in that case, whenever IoT service A and B publish to here, then the information will be published to COP, complex event processing here. And at the same time, so the user may subscribe to the service choreography for information to service C. So it's at the left upper corner here. So in the case, whenever something is published by C, so the published content will be forwarded, will be pushed to the user. So that's another scenario. Okay, let's come to the last part. So that's the deployment and operational view. So the deployment and operational view depends on specific actual use cases and requirements. So basically, it means that we need to have specific examples. So let's come to the parking lot again. So that's the scenario here, the parking lot deployment and operational view. In that case, we will see that we have the sensor nodes. So remember, each sensor node consists of 8 sensors. So one sensor node deals with 8 slots because there are 2 slots, right? And then for these sensor nodes, it's connected to the what? Payment station. And also it is a gateway. Gateway means that it's where the system is connected to the internet. So in other words, the sensors themselves are not connected to the internet. They need to be connected to the gateway. So as we can see here, first, and then the information or the update will go through the gateway to the internet. And also we have another gateway here attached to the smart sign. So what it does is that it receives updates of the empty slots and then display here. So in other words, the sensors and the smart sign, they actually are not connected with each other directly. They need to go through what? They need to go through the internet, actually maybe the data center, to update the smart sign display of the availability. So basically the sensor node does not go directly to the smart sign. It needs to go to the internet, go to the data center, and then from the data center go back to the other gateway, and then go to the availability sign. So there are 2 sensor nodes. Let me change the color of pen. And the payment station acts both as a user interface for the driver to pay and get a payment receipt, of course. And also it is a communication gateway that connects 2 sensor nodes and the payment interfaces with the internet. In other words, the sensor nodes do not connect to the internet directly. And then the occupation sign can act as a communication gateway for the activator node because, well, the activator node, which is the display of availability, needs to be connected to the database so that it knows the current empty space, right? So the 2 main applications connected to this management system are human user mobile phone applications and parking operator center applications. How they interact can be shown here. If you, I recommend you to read this description so that you will know how the flow of the operation goes. Okay, so if we put the deployment view, parking lot deployment and operation view, so it will look like this. So basically it is very specific, including the sensor node, the gateway, so we can clearly see that there are two gateways, right? And for the first gateway, it deals with sensors. For the second gateway, it deals with the activator node. They all need to go to the internet. So if after they go to the data center, these are the operations they will do. So we can see application 1, which is the mobile phone, and application 2 is the remote operation and management using the information. Okay, so this figure shows a more generalized implementation by mapping the IoT domain model and concepts, IoT domain model concepts to deployment view. So if we talk, in the case we will see the advanced devices, basic device. So for this figure, actually we show 5 possibility, 5 options to implement. Okay, sometimes we can use a combination of basic device and advanced device. Sometimes we just need to use advanced device directly. But once again, we can find this IoT domain model objects, right? So for example, we have the virtual entities and also the different components of the IoT domain model. So once again, I recommend you to read these a few slides so that you see some different options for implementing. Okay, so that's all for this class.